welcome back to our presentations. We have 3 more up in the string, but 4 more overall, so if you stay for the rest of the day. And this presentation is going to be on Beagleboard.
Sure. Hello, everyone. My name is Xiang Jian, and I'm going to talk about Beagleboard today. So for this talk, first I'm going to introduce what is Beagleboard and what can Beagleboard do. Then I'm going to talk a little bit about the kernel development of this. I'm not going to do the detail like how you do this, do that, but I'm going to tell if you want to do some kernel development on Beagleboard, there are some things you may consider knowing, and you may be facing some problems. Later, how are you going to solve these problems? So let's get started. So what is Beagleboard? The Beagleboard is a low power, low cost single board computer produced by TI. Well, it was designed with open source. Well, this is actually excerpted from Wikipedia. Well, when I first see this, I don't really have a clue about Beagleboard. What is Beagleboard? What does that mean? Okay, it's open source. It's low cost, low power, but what is it? So when I first see the name, Beagle, reminds me, what? Beagle? Well, the first thing I think is this. Of course, I'm talking about the dog in the back, not the cat in front. I mean, what? Beagle? I thought that is Beagle. Why do you want to call it board Beagle? Then I look up some data, then I figure out, okay, this is where the Beagle comes from. It means bring your own peripherals. It's the entry-level cost at $149, and it has an ARM Cortex A8 processor. It has graphics and DSP. It's Linux, and the environment for software in Windows. So that's how the Beagle comes from. So this is Beagleboard, and here's one. I'll just pass it down. You can have a look. So yeah, if you look at this, you'll see. Okay, basically it has a ARM Cortex A8, and it has 512 megabytes of RAM. It has a graphic processing unit, and it has all kinds of like peripheral. That it has 4 USBs, and it has a DVI-D to connect to computer monitor, and it has S-video, and it also has like stereo, the audio, and the Ethernet, pretty much everything. So what you can really expect from this board is actually, it's not like very like traditional embedded system. It has very, very limited power. It's more like a, I would say it's more like a small computer, just like the Raspberry Pi, which was introduced by Tim. Yeah. I'll talk a little bit about that later. Yeah, so what you can really expect is like a small version of computer with, of course, somehow limited processing ability, but it's still a computer. So this is the hardware part of Beagleboard. What about the software? Of course, it supports 12 of Linux distributions like Angstrom, Debian, Ubuntu, Android, and GXbox. Well, for the Beagleboard, the most popular one is Angstrom. It's also the pre-installed one, and the most developers are developing on this platform. So the following talk will be focusing on this platform, this distribution, Angstrom. So, what can Beagleboard do? Well, currently there are over 300 registered open source projects, and some of them are like Beagle SNES, Beagleboard Secure Home, Photo CamCom, well, continuous integration, blah, blah, blah. I don't know what that is. And Beagleboard. I'm going to show that later. And there's many more, but I just want to use these examples to show what can Beagleboard use, what kind of applications it has. So this is the first one, Beagle SNES. Apparently this is a Super Nintendo emulator. So obviously Beagleboard can be used to play games. You can hook up your keyboard and even controller, gamepad to play games. By the way, this is one of my favorite games. So Beagleboard Secure Home. It can also connect to like all kinds of like for this one, this is a buzzer, and it can connect to LED, and it can also connect to temperature sensors, so it can work as a controlling center. It can control, and using these sensors to detect the environment, the security of your home. Also, the Photo CamCom, you can use it to control DSLR, of course. Then it's the continuous integration traffic light. Basically, it's a traffic light. You can use it to control traffic light. Then this is the Beagleboard. Of course, you can use it to control the robot. So this is one example. Somebody built this project, and you use it to control a robot. So when you got the Beagleboard, it's gonna look like this. This is the box. So what are you going to do? Well, basically it comes with the pre-installed Angstrom operating system on a 4 gigabytes micro SD. So if you want to start using it, the simplest one is plug in the DVI-D to your monitor, Ethernet, mouse, keyboard, and plug in the power. Then your Angstrom runs. This is what you're going to see. But unfortunately, I'm not going to talk about this, but I'm going to focus on if you want to do some kernel development, what do you have to do? Well, if you want to develop kernel, there's a little bit more you have to do. You have to connect it through the serial port, the RS-232 cable, and connect to your host computer, whatever it is, doesn't matter, and set up the bound rate and everything. Start a power, then you'll be seeing a screen like this. It will be printing all kinds of messages from the bootloader to the kernel loading. This is where you want to start if you want to develop kernel. Then I'm going to talk about the boot process of Beagleboard. So first thing is, why do I have to talk about it? Why is it important? I mean, it's all done, right? I mean, it comes with the pre-installed operating system. You just plug it in and you will just boot. Why do you care about this? Well, unfortunately, if you really want to do kernel development, there's a high chance you have to know this and you may need to modify some of them. So I'm going to talk about the process. Basically, the Beagleboard boot process is divided into 4 stages. The first one is the run code, which is actually this part happens in the TI microprocessor. It's a small run. What it does is not really much set up like the minimum clocks, and it search for the boot device for Beagleboard. It's going to search for the micro SD to search for next level of bootloader. Then it's going to load the next level of bootloader, which is the X loader, into the SRAM. I'm sorry. Then what does X loader do? It will set up things and initialize clock and memory, and will load the U-boot into the SD-RAM and execute it. Later it comes to the U-boot. It will do more things, set up the environments, and eventually will load the kernel image. Eventually you'll be loading the kernel. So when I first see this diagram, my first thought is, why does it have to be so complicated? I mean, it's just like one stage and load next stage, and next stage doing a little bit of thing, and loading the next stage, doing some more things, and load the kernel. Why does it have to be so complicated? I mean, couldn't just like the ROM just directly load the U-boot or even load the kernel? Why does it have to be 4 stages? Why does it have to make life so difficult? Well, there are reasons. One of the reasons is when the run code starts running for this microprocessor, it only has like 32 kilobytes. And in this so limited size, there's not much you can do. At that level, the only resource you have available is the SRAM on the microprocessor. You don't have the 512 megabytes SD-RAM ready yet. So you couldn't load anything that is large. So that's why you have to load the X loader, which is very small. And loading the X loader, one important thing it does, it will set up the memory for you. So after this setup, you have the SD-RAM ready. Then you can load the larger U-boot to set up more things to load the kernel. That's one like important logic inside this kind of design. I don't really know about Raspberry Pi, but I believe it's still going to be like at least 2 or 3 stages of boot process.
Yeah, I believe the Raspberry Pi doesn't have anything on the chip. All it does is tell it to
directly
go directly to the SD card.
Yeah, so that's another kind of boot process. But basically the idea is you have the resource very limited from resource that you have more, so you need multiple stages of boot loading. That's how you accomplish it. Then I'm going to talk about how to build your own Angstrom. Yeah, just first question, why do I need to? I mean, those Angstrom kernel comes pre-built inside the micro SD card. And if you think, oh, it's kind of old, it's kind of outdated, there's always a pre-built version on the internet. You can just download it and plug it in, then start using it. Why do you have to build it yourself? Well, unfortunately, if you really want to do kernel development, you want to modify things, you want to modify drivers, you want to modify the kernel, you want to modify the boot process, you have to know how to build it. Because you're going to modify it, you have to build it yourself. So, how to do it? Well, here are like commands you have to do. You have to do this and run that, run that. I'm not gonna like line by line explain what that does, because that doesn't really make any sense to talk about it here. But I'm just trying to say, if you want to build a kernel, you have to run some commands to do that. But I do want to point out one thing, that under those commands, there are some things you may want to know. Like for the Beagleboard, for the Angstrom, it's actually built upon the Open Embedded. It's a software framework for building Linux distribution. And for the Open Embedded, it actually involves bitbake, which is pretty much like the make everybody will use on the Linux, but it's especially optimized for embedded Linux. Also, when you use this, where does the source code come from? Well, for Beagleboard, for Angstrom, it comes from the GitHub. So you'll be involving this. So these are the things that will be involved inside the kernel building process. So, well, building kernel, you'll be able to find a lot of like tutorials like the one I just showed. This is actually exerted from one of the online tutorial things. We'll just tell you, first step, you do this, do that, then you're done. Yeah, well, if everything went right, it's fine, it's great. You don't really have to understand what those means, what each commands mean. No, you don't. You just, after build, you pick up the thing that the result is, put it in the car, and it's done. But, well, sometimes it's not going to go that easy, because something will go wrong. So, under these kind of circumstances, what can you do? I mean, what can you do to solve the problem? Well, for me, it always comes to Google. Well, some problem happens, I just Google it. There's almost always a solution, at least something related. But for Beagleboard, if you want to Google, you have to know like at what stage of the building process that went wrong, or what kind of error message you have, then you'll be able to Google. Otherwise, you couldn't just Google Beagleboard, Angstrom, build, fail. That's not going to return anything helpful. So that's why I said you may need to know these structures, these frameworks. Yeah, because if something went wrong, you'll be able to know, okay, maybe the bitbake process wrong. There's something wrong with like the processing the recipe, or there's something wrong when you're grabbing the source code from the GitHub. So that's why you need to know this structure. You'll be able to diagnose what part is wrong, then you'll be able to Google. That's one thing. So, except for Google, well, there are, of course, error message. When it fails, you'll see fail and some error message. That is helpful, of course. But for this kind of kernel building, except for the error message, you also have the error log located somewhere. You'll be able to find it. Yeah, it will have like very complete error message about what kind of error this is and what actually went wrong during this process. This is very important for debugging, because a lot of times you just see the error with some arbitrary error code, but you don't really know what that means. This error message and even error logs will help you on that. So you have to diagnose that, you have to really look into the error message. Also, one thing is, I don't know how many of you have ever like built a kernel. Basically, it takes hours of time, and starting from the point you start building it, you will start to pop out a lot of message. After it's done, it's gonna be thousands of lines of message. Sometimes you have to go through let's say you got an error here, but you have to go through all the source to the very top, even at the beginning, to be able to find actually what is went wrong. So a lot of times when I'm trying to debug this kind of like building error, I have to read through a lot of different kind of error message to see what actually happened. Well, another way is, of course, you can ask. Now, for this kind of open source community, there's like very actively forums well, for the Beagleboard, it's actually hosted by the Google forum. So if you got some problem, you can ask there. But how to ask the question is important. Imagine today you got something wrong. So you go to the forum and say, help, my Angstrom building is wrong, somebody help me. I believe you're probably not going to get any positive feedback. So what is like a good message that can make people help you? Of course, you have to understand, okay, I'm trying to build it. What is my host computer? Maybe Ubuntu, maybe something else. What version is it? And what command did you run? And at what phase when it went wrong? And what kind of error message? With this message, the open source community will be able to help you. But without this, there's no way people can help you. That's why you need to understand the different phase of the building. And last, wait. I mean, what does wait mean? What are you waiting for? Well, my personal experiences, when I started dealing with that, I faced, at one stage, something went wrong. I couldn't find any answer to that, and I don't know how to solve it. So I kind of stopped and I worked on some other things, and 2 weeks later, I did the same thing, but it just worked. I mean, why? What's wrong? I mean, some magic happened? Yeah. Then later I tried to dig out. I figured out 2 weeks before that point, when I'm trying to do the build, it will grab the source from the GitHub. But somebody committed some bug, some code with bug in that version. That's why the building went wrong. This kind of thing happens in the open source community. I mean, everybody's kind of actively committing to the source. Yeah, but sometimes bug will happen. Yeah, and after you try all the way to Google, then see the error message and ask if nothing helps, well, sometimes just step back. Maybe someone else will fix it. Maybe somebody else will fix it. So this is for the bug in the kernel. Okay, for this page, I'm gonna talk a little bit about Beagleboard and Raspberry Pi. So since they are all alike, well, basically Raspberry Pi is a little bit smaller. It's roughly like 2/3 of the size of Beagleboard. But if you see them, you'll see they're all based on ARM structure. They all have a graphic and CPU, and they have the same amount of RAM. Has SD card, has different number of USB ports, and it has many different ported Linux distribution. But if you really look into that, of course you're gonna find out that, okay, ARM Cortex-A8 is basically faster than ARM 11, and the frequency is higher. But if you really try it, the difference is, I would say, not that much. So if you're today considering doing, okay, I want to do some cool thing about this embedded system, I want to pick up either Beagleboard or Raspberry Pi, I would say the best way is to try it yourself and to see like which community you really likes and what kind of applications you want to work on that is available. That is more important, I would say, than the hardware difference. Oh, of course, Raspberry Pi is cheaper. A lot cheaper. That's one thing to consider, I have to say. Yeah. So it really comes down to the software side instead of the hardware, because from the hardware side, not that much is different. I mean, Beagleboard is faster, but it's not so fast that something can be done on Beagleboard that cannot be done on Raspberry Pi. I would say so. So that's the brief comparison. So, any questions?
Do you do any cross-compiling on another computer to try to speed up your kernel development or kernel compile?
Yeah, I did. There are some configuration you can set, but basically for the Beagleboard, I've asked someone else, it just takes roughly that long. It's common for building Beagleboard kernel, it's common to take like overnight time, 7 to 8 hours, it's common for this. Yeah. Any other questions?
I have a comment. Typically, you would build the kernel on a different system.
Yeah.
Yeah.
So what is it in kernel hacking? What can you do with it?
Well, you're talking about kernel part? Well,
Just in general.
Well, in general, hacking the kernel of Beagleboard is just like hacking up the kernel of other devices like Raspberry Pi. Well, for my project, I'm more focused on the kernel debugging part. Yeah, that's my focus.
How happy were you when you realized that when you waited to actually start the work?
You mean the wait phase?
Yeah, the wait phase.
Very happy. I mean, I just couldn't figure out. Like Google, I've asked everywhere as far as I know, and I checked the error message. It just doesn't work. Yeah, it just simply doesn't work. Yeah, very happy.
Any other questions? Okay, well, thank you very much. And our next presentation starts at approximately 6:10 up here in downstairs, whatever one you are 10 minutes ahead.